Have you ever wondered why your coffee cools down or why things seem to fall apart over time? Hi everyone. Today we're diving into a concept that touches every aspect of our lives and the universe itself: entropy. It's a fundamental idea in physics that explains why your hot coffee gradually cools down and why everything from a neatly arranged room to the universe at large tends to move towards disorder. Understanding entropy isn't just about grasping a scientific principle. It's about unlocking a deeper understanding of how the world works. It has implications for everything from the way we use energy to the fate of the cosmos. Let's start with the basics. What exactly is entropy? In simple terms, entropy is a measure of disorder or randomness in a system. Imagine you have a deck of cards. When you first buy it, the deck is neatly ordered by suit and number. But as you shuffle the cards, they become more and more disorganized. This increase in disorder is essentially what we mean by entropy. In the realm of physics, entropy is a central concept in thermodynamics. The second law of thermodynamics tells us that the entropy of an isolated system will always increase over time. This law explains why natural processes tend to move towards a state of greater disorder. For instance, when you drop an ice cube into a glass of warm water, the ice melts and the water cools down until everything is at the same temperature. The system has moved from a state of lower entropy to a state of higher entropy. We can see examples of entropy all around us in our daily lives. Think about a tidy room. Over time, without any effort to keep it clean, it will inevitably become messy. Or consider a hot cup of coffee left on the counter. It will gradually cool down as heat spreads out into the surrounding air. Both examples illustrate how systems naturally progress towards greater entropy or disorder. To really grasp why entropy always increases, we need to zoom in and look at what's happening at the microscopic level. On this tiny scale, particles are constantly moving and interacting. In an ordered state like a solid, particles are tightly packed and have limited movement. But as energy is introduced, think heating up that solid, particles begin to move more freely, leading to a more disordered high-entropy state like a liquid or gas. One key aspect of increasing entropy is energy dispersal. When energy is added to a system, it doesn't stay concentrated in one place. Instead, it spreads out. For example, if you pour hot water into a cooler glass, the heat energy from the water will naturally spread out to the cooler parts of the glass and the surrounding air until an equilibrium is reached. This spreading out of energy contributes to the overall increase in entropy. Now, let's touch on the statistical nature of entropy. This is where the concept of statistical mechanics comes in. In simple terms, statistical mechanics explains that systems are more likely to be found in states with higher entropy because there are more ways for a system to be disordered than ordered. Think of rolling a pair of dice. There's only one way to get a total of 2. But there are multiple combinations to get a total of 7. Similarly, there are far more ways for the particles in a system to be disordered than ordered, making higher entropy states statistically more likely. Let's take a step back and look at the bigger picture, how entropy plays a role in the entire universe. The universe started off in a state of extremely low entropy with the Big Bang. Imagine a tightly packed, high-energy state where everything was uniform and ordered. But since that initial explosion, the universe has been expanding and evolving towards higher entropy. This increase in entropy has driven the formation of stars, galaxies, and the complex structures we see today. Now, consider the concept of the heat death of the universe. This might sound dramatic, but it's a scientific theory about the ultimate fate of the universe. As entropy continues to increase, energy becomes more evenly distributed, and the differences in energy levels, which are essential for doing work, diminish. Eventually, the universe could reach a state where everything is spread out evenly, and no useful energy remains to fuel processes like star formation or even life. This theoretical end state is what scientists refer to as the heat death, a point where the universe reaches maximum entropy and essentially becomes inert. We can observe the effects of increasing entropy on a cosmic scale. For instance, the expansion of the universe itself is a sign of increasing disorder. As space expands, galaxies move farther apart, and the overall structure of the universe becomes more diffuse. Additionally, the distribution of galaxies and cosmic background radiation are evidence of the universe's journey towards higher entropy. These observable phenomena provide a glimpse into the ever-increasing disorder that governs our universe. There are a lot of misconceptions about entropy that can make it a bit confusing. One common misunderstanding is the idea that increasing entropy always means things get more disordered in a chaotic sense. While it's true that entropy is about increasing randomness, it doesn't mean everything turns into a complete mess. Instead, it's about energy spreading out and becoming less useful for doing work. Take living organisms, for example. At first glance, it might seem like life defies entropy because living things create order. But organisms maintain their internal order by increasing the entropy of their surroundings. When we eat food, our bodies convert it into energy, releasing heat and waste products in the process, which contributes to the overall increase in entropy. So, life doesn't break the rules of entropy. It works within them by constantly exchanging energy with the environment. Another interesting point is the concept of reversibility. Certain processes, like mixing two different substances or diffusion, seem irreversible because of entropy. Once you mix the cream into your coffee, you can't separate them back into distinct layers. This irreversibility is a direct consequence of increasing entropy. The mixed state has higher entropy, and returning to a lower entropy state would require an improbable amount of energy and coordination, making it practically impossible. Entropy doesn't just have scientific significance, it also has profound philosophical implications. One of the most intriguing aspects is how it shapes our understanding of time. The increase of entropy gives time a direction, often referred to as the arrow of time. This is why we remember the past but not the future, and why processes in nature appear to have a preferred direction, like ice melting or a cup shattering. From a human perspective, acknowledging entropy can offer a new way to appreciate life and our environment. It reminds us that everything is in a constant state of change and that order is temporary. This can be a humbling realization, but it also highlights the beauty and fragility of organized systems, from ecosystems to our daily lives. Understanding entropy encourages us to cherish moments of order and harmony, and to be mindful of how we manage energy and resources. Looking ahead, research into entropy continues to be a vibrant field in fundamental physics. Scientists are exploring how entropy interacts with other physical laws and what this means for the fate of the universe. For instance, there's ongoing work to better understand black holes and the entropy they contain, which could unlock new insights into the nature of reality itself. By delving deeper into the mysteries of entropy, we may uncover new principles that govern the cosmos, and perhaps even find ways to harness its principles in innovative technologies. To wrap things up, we've explored what entropy is, the science behind its increase, its impact on the universe, common misconceptions, and its broader implications. Entropy is a fundamental concept that not only explains many natural processes, but also prompts us to reflect on the nature of time and the universe. Now, I'd love to hear your thoughts. What do you think about the inevitability of entropy in our lives? How does it shape your view of the world? Drop your thoughts in the comments below. If you enjoyed this video, don't forget to like, subscribe, and share it with your friends. With that said, thanks for watching, and until next time.